basically instantaneous rate of change, right? So when there is a change, we use y2 minus, y2 minus y1, rather final velocity minus initial velocity upon final time minus initial time, right? So that's what we do. That is what speed is. But if I talk about derivative rate of change, that means what? It's instantaneous rate of change. That means here, if there is this point f of x plus h would be just next to it upon x plus h upon x plus h minus x, which is nothing but h. Okay, it's very small. So that's why so this is also known as first principle. What about derivatives list? So I hope you know x to the power of n is nothing but n x to the power of n minus 1. I think you are quite comfortable with that, right? Ln x 1 by x, sin x, cos x minus sin x, tan x, x square x. Derivative of constant is 0 because there is no change. There is no change as in like there is no rate of change, right? It's just constant speed. That's why. Rules simple. You can separate it from the plus minus, right? Whenever we are differentiating f of x plus minus k g of x, then we can just separate from the plus minus, and also we can keep the k constant outside. I've given you one example also, 5 sin x minus 3 e to the power of x, of course. Product rule, first into second derivative plus second into first derivative. Quotient rule, denominator into derivative of numerator minus numerator into derivative of denominator upon denominator whole square. Just remember one thing, for product rule there is plus, and for quotient rule there is negative. Okay, maybe you can say that division is generally it's lesser quantity, so that's why we'll just subtract. Chain rule, everybody is comfortable with that. F of g of x, composite functions, right? So we'll find the derivative of the outer function, then we'll go inside whatever. Okay, how to identify whether there is a chain rule or not? Remember, this is also important in integration. Okay, you need to understand where you get a composite functions. So if I have sin x into cos x, I'll put x is equals to 5. I'll get the value directly, like sin 5 into cos 5. But if it is sine of cos x, and if I put 5, then I'll have to find value of cos 5. That value I'll have to put, and so basically I'll get 2 steps, right? So in chain rule we'll have 2 steps. Now number of function determines how many derivatives we'll have to do. So if there are 3 function, log of tan of sec x, so there are 3 functions, so derivative would be of 3 functions, like that, stepwise, outer, inner, like that. Okay. Applications. So if the first one is gradient of a tangent, right? Now see, we know gradient is y2 minus y1 upon x2 minus x1. So we can consider f of x plus h as y2, f of x as y1, x plus h as x2, and x as x1. So y2 minus y1 upon x2 minus x1, that is nothing but the gradient. But the thing is here, since the limit is very, like the value of h is very, very small, the points are just next to each other because it's instantaneous rate of change. So that's why it will become a tangent directly. So the 2 points are almost 1 point. Make sense, right, everyone? Okay. So f dash of x gives us gradient of the tangent. So in short, whenever we want to find gradient of the tangent, we'll find f dash of x, put x wherever we want to find the tangent at. So for example, at x is equals to 2, 3, 4, 5, just put the values, you will get various tangents. Okay. Now when I find the tangents, so from that we get the application 2, which is stationary points. So in that stationary points, so as you can see, when the function is rising or it's increasing, that time the gradient is always positive. You can see that here. So it's tilted like this. But when it is decreasing, the tangents are like this, though you don't have increasing decreasing function. Huh? So the derivative of 10 e power x will be 10 e power x. Yes, 10 constant outside, derivative e to the power of x, e to the power of x. Okay. But there are, see, you don't have increasing decreasing function, just letting you know that, at this point, the tangents are like this, so it's negative. But at this point, we have tangent like this or like this. So that means what? There the derivative is 0. Right? The derivative is 0. So there either it's going to be the maximum value or it's going to be the minimum value. Either it's going to be the maximum this value or it's going to be the minimum value like this. Okay? But how to determine whether it's a maximum or a minimum? So anyways, for this thing, as you can see, gradient at 2 is 4. So I'm just assuming, I don't know whatever it is. At 5 and 10 it is 0, but we are not sure whether it's maxima or minima. So for that we will differentiate it twice, so double differentiation. So we'll differentiate the function twice, and we will substitute x is equals to whatever that value. And if I get negative, then it is maxima. If it is positive, then it's minima. If it is zero, then it is point of inflection, which you don't have. So either it's going to be negative or it's going to be positive. Whenever
Her
it,
teacher did tell us once about point of inflection.
huh?
She told us once about point of inflection.
Nobody will ask you, but don't worry. अभी एग्जाम ओरिएंटेड है ना, थोड़ी ना स्कूल ओरिएंटेड भी यार, राइट. हाँ. So point of inflection, this ऐसी information I've given you, not important. So negative or positive you will get, but remember negative stands for maxima, positive stands for minima. I think I've given you one weird example as well. So when I'm differentiating twice, right? So I'm talking about this next point, and this next point would be negative, like that, for maxima. Here also, if I'm differentiating again, so next point I'm talking about, so again differentiation would be positive, like it will go up. Okay. Now the third application is small increment. This is something thoda, generally 1 or 2 marks question they ask you, right? Or how much is the increment or whatever, generally after that f of x. Now see, obviously everything is based on the first principle, right? F dash of x is f of x plus h minus f of x upon h. Now I just shifted here and there, so I made f of x plus h as the subject, this thing. So I got f of x plus h as f of x plus h into f dash of x. Remember, h is very very small, okay? So therefore there is this small increment. This is only valid when the value with which we need to differentiate, that's going to be very very small. As in, see, here it is 2. Like, see, if I want to find where is it, question ka? If I want to find 2.001 to the power of 3, okay, so as you can see 0.001 is a very small quantity. So this can be written as, so I'll consider f of x as x cube, so f of 2 is 2 cube, and f dash of x is 3x square. These three things we need to understand, okay? Now the thing is, if I'm doing f of 2.001, if I'm doing f of 2.001, that is nothing but f of 2 plus 0.001, right? So 2 plus 0.0. Now see, this is your a, this is h, okay? So f of 2.001 would be f of 2 plus h into f dash of 2, small increment, okay? That from like with what we are doing, actually we are comparing this f of 2 with f of 2.001. So compared to that, the value is going to be just this much increment we will get with respect to this f of 2, and then we just put the values and we get the answer. Remember, this is the small increment. Now see, most of the question they ask you how, what would be the, like, kya likhte hai wo? By how much value it will increase or decrease, they will ask you. So you'll just have to write h into f dash of a. So in previous question, they will ask you f dash of x, okay? They will ask you f dash of x, whatever that thing, and then they will ask you if it has been increased from 2 to 2 plus h. If it has been increased from 2 to 2 plus h, then how much is the increment? It's going to be h into f dash of 2. Now this value you need to figure it out, like you'll have to put that value in the question, and then you just have to multiply by h. H means they will literally give you h, not like h ka any value. Did you get it?
So, and then if the tell was the value of y for this new value of x, then do we add f of
Then
x
this
to
thing,
them?
yes. Then we will add f of a to this thing.
So when do we put this in the whole equation again and get that value of y? Because in I think previous marks we had to do this in mark one.
This one adding up.
Yeah, and I added f of x, but it was wrong. We had to put this whatever h into f dash of x in the whole equation again, and we get the value of y.
No, f of a you need to put, like for example f of 2, and then you have to add also h into f dash of 2.
So yeah, I used this formula, but it was not right.
No, this is
We
the
have
only formula.
to, then the question might be something else. Then
Probably.
what kind of question do we put it back in the equation?
See, I told you, na, see, for example, for this particular question only, if I talk about 2 and 0.001, now instead of that, they may give you h only, like not 0.001. So if they ask you how much is the increment, then it's going to be h into f dash of 2. Okay, that is nothing but h into 3 into 2 square, which is nothing but, as you can see, 4 into 3 12. So it's going to be h into 12. That much amount of increment, 12h. That's the answer. But if they ask you what would be the new value, or exactly f of 2.001 or 2 plus h, what is it going to be? Then it's going to be f of 2 plus this thing, and f of 2 is nothing but 8. So it's going to be 8 plus h into 12. Did you get it?
Sir, find that question send it. Or I'll calculate it.
ठीक है, no problem. So as of now, 8 plus h into 12, that would be the total increment. But the total new value, and what would be the increment? It's going to be h into 12. Correct? Clear? And now we have application 4, which is related rates. Okay. Now general, just I've used an easier example. So if f is a function of g, g is a function of t, then f is also a function of t, of course, right? So maybe you can consider it as a composite function. Now see, assume you throw a stone in water, one ripple is formed. Okay. So with respect to that ripple, radius is increasing, area is increasing, circumference is increasing, but all these things are increasing or changing because of this element, which is time. I don't know what yeah, B join kar diya. Just a second. Changing. Now the thing is, let's say A is equal to pi r square. That's the formula. Now if I differentiate with respect to t, I'll get dA by dt as, see, pi is a constant, pi constant outside, derivative of r square is 2r into dr by dt. Remember, see, Dylan, especially you have to differentiate with respect to 2. I know you are using dA by dt as dA by dr into dr by dt, but I'll still prefer that you use one technique for everything, because this you will use for the optimization, I mean this other application as well. So just differentiate with respect to t. So yeah, it's going to be, in general, when I say that, if I say y is equals to x square, see, if I differentiate with respect to x, so dy by dx, x square would be 2x into dx by dx. I'm differentiating with respect to x. Okay, here also I'm using chain rule only. Derivative of x square 2x into derivative of x with respect to x, which is dx by dx, which is nothing but 1. So that's why we don't write this thing. So we get dx. But if it is r square, so it's, and provided obviously it's a function, so it's going to be 2r into dr by dx. Derivative of r square with respect to r, so 2r into dr by dx. At the end of the day, I'm doing the same thing, that I'm differentiating dr by I'm differentiating d this whatever with respect to r into dr by dx.
dy by dr.
हाँ, so wait, that way only. So this, whatever this bracket I'm talking about.
So why do we need to write dr by dx after doing this?
I'm doing this thing because just to tell you that whenever we are doing with respect to t, we consider that as a function. Area is a function of radius, and both are the function of t. So I'm differentiating with respect to t. So I'm dA by dt and pi into 2r into dr by dt. See, I have mentioned also dA by dr into dr by dt, which is nothing but dA by dt. Okay. Steps: write down the given condition, form an equation in terms of just one variable. Okay. This will all this same steps will be for optimization as well. Okay, there will be some certain condition and differentiate it with respect to t. Why I mentioned this one variable? Because when we get questions with respect to cone, I've already given in that revision worksheet as well. So they give you semi-vertical angle is 30 degree, 60 degree, that kind of stuff, right? So that time we use sine 30, tan 30 kuch to bhi we use, and then we write h in terms of r or r in terms of h, and then we differentiate. Correct? Generally sphere ke liye there is no issue. Cylinder there is an issue, because see, volume is what? Volume is pi r square h. Here there are two variables, r square and h, but we'll make sure either you convert r in terms of h or h in terms of r. Quite possible. Okay, and then everything will be in terms of one variable. Then you differentiate with respect to time, and you will get whatever the change you need. Okay, and then you just put the values, because they will ask you area dA by dt at r is equals to 5. Obviously they will give you one of the condition, at what rate radius is changing, or at what rate area is changing. So they'll give you one of the conditions. And please remember one thing, that at every instant like say dr by dt is constant, radius is constant, constantly increasing, no problem. But dA by dt could be different at various instances. At that particular time when r is equals to 5, that time maybe radius is changing at a huge pace, 10 huge, okay, one take a small increment would be there. So area will be changing with respect to time, and it will be increasing here in this case. Okay, some of the things which they give you constant as volume, sometimes they give you that the volume is constant. That is actually for optimization. One sec. Now see, optimization, maximum or minimum. So again, here you need to figure it out, that whether the surface area has to be minimum, volume provided volume is constant. Then they may say that volume is variable but surface area is constant. Yet, like you need to make a tin or some box where the surface area is constant but you have to maximize the volume. So what kind of thing you will get? So that time you will use optimization. First thing, you will convert everything in one variable. Again you will differentiate. This time we are talking about maxima or minima. So we'll get f dash of x is equals to 0. Okay, we'll equate that f dash of x to 0, and we will get 1 2 3 values, whatever we are going to get. Generally we'll get 1 or 2 only, and just we need to confirm whether it's a maxima or minima by doing double differentiation. Correct. Now in general, square are the most like they give you the maximum volume provided you have a limit of circumference. Square, like a symmetrical shape in short. So wherever you want to maximize the volume or anything, that time it's always going to be symmetrical shape. Okay, and if you want to minimize it, then it's going to be a weird shape. Okay, for example, this square, and if the perimeter is same and there is this rectangle, of course the volume of this thing, volume not area of this square is huge, and area of this rectangle is small. Perimeter is same throughout. You may get question, I mean various questions you can get anyways. So we'll look at the questions as well. Okay, so these are the applications and whatever the derivative stuff is there. Tell me any doubts.
So why will ask minimum for irregular shapes? I didn't understand. Can you repeat what you said?
Minimum, that minimum volume or area. Acha, that symmetric, see, for example, let's say 40, okay? If I say that the dimensions of this thing is 10 10 10 10, this is just an example. Every time, see, this is applicable for cylinder as well. So if it's a square type cylinder, square type as in the height and radius are equal somewhat, diameter to be precise, then volume is huge. But if the cylinder is like this, the volume is less, though the surface area is same. In
Okay.
simple words, this is 10 10 10, perimeter is 40. Now if I consider like this, let's say a rectangle of uh, 15 15 5 5. Of course, now see, look at the area. The area is only 75, here it is 100. This is the maximum area you will get always whenever it's a square. But they will confuse you with respect to that also, that one side is a wall, then there is this fencing. Now the problem is that if this is x, this is x, this is 50 minus x, something like that, perimeter is like that, so they can
And
confuse you
then
with that.
so we'll have to show that double differentiation thing, no?
So most of the time when you do double differentiation, that time you get a constant only, positive negative, most of the time.
So what do we do with the constant? We just say it's
Constant
lesser
with the
than.
positive है ना, so it's going to be positive. The answer is positive, so minima. Answer is negative, it's maxima. Acha, worst case, I don't think so you will get it, but in case if you get a very weird question, so maybe let's say sin x plus tan x, see, just normal I'm saying, minus 4x but with whole square. Now obviously you cannot put values of x, let's say this is f double dash of x, obviously you won't get it like this. But logically also you can say which is always going to be positive. You put any value of x, it's going to be positive. Why? Because it's a square, right? Sometimes you will get 1 upon this thing. Now you don't have to solve that, you just have to show, yeah, it's which is I mean, even if you write like this, which is greater than 0, that's it. So then therefore it's a minima. They are not looking for f double dash x ka value, they're not at all looking for that. Okay.
So for bubble differentiation, only the sign matters. Like even if we get 175, so they won't
Yes.
ask us which one is greater, no? Like nothing like that.
Nothing like that. Only
So
positive,
even if the
negative.
value of the constant is wrong, but if it's just a right sign, it's okay.
Yes.
Oh.
Even in mark scheme, they won't give you that f double dash of x needs to be like this. No, they will just ask greater than 0, less than 0, maxima, minima. That's it. Right? And of course, from the question also, you can understand whether it's maxima, whether it's going to be maxima or minima. So you always know, yeah, it's going to be greater than 0, less than 0. Okay. 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 Let's start with some of the questions then from the past papers. Okay. The same document.